Hello, everybody. So today we're going to be looking at static electricity. I know we started this right before March break, but we're going to spend a bit more time just kind of looking at it again, and then in our second lesson we'll get into a lot more new stuff. So first thing is our term static electricity. What does static mean? And static just means stationary. It means that something is not moving. So when we're talking about static electricity, we're talking about electricity that's not moving. We're talking about electrons that are not moving. They're stuck on an object. And you've probably experienced this yourself. If you've ever, walked across carpet with socks on, sometimes what will happen is you'll build up electrons on yourself, and when you go and touch a doorknob, you'll feel a zap. And what that is you have a static charge on you, and when it has a place to escape, you can feel when it leaves your body and goes to the door handle. So this actually links back to chemistry too. So if we go back and look at our picture of the atom, the Bohr-Rutherford diagram that we practiced drawing. All right, let's look at the different pieces of the atom here. So proton, those are our positive ones. Those ones show up in the nucleus, in the center of it, and they had a positive charge. Neutrons, in that nucleus, there were also these red neutrons there, and they had no charge. These were all clumped up nice and tight in the middle. And then around the outside in these orbits, right, we had our magic numbers 288. So in these orbits are the electrons. So orbits or electron shells. Now, when we're talking about static electricity, it's these electrons that matter. Because they're on the outside of the atom, it's easier to remove them and switch them to a different atom. And that can happen just by rubbing different materials together. So when different materials are rubbed together or bump into each other, electrons, the green ones here, are going to leave one surface and then collect on the other surface. So with the example we talked about earlier, when your socks were rubbing on the carpet, there were electrons that were moving between the socks and the carpet, and that just happened because they were being rubbed together. And it's those green electrons that would transfer. Now, remember that those electrons have charges. So if one of your materials gains a bunch of electrons, it has a bunch of extra electrons, which are negative, then that object will become negative. Now, those electrons had to come from somewhere, right? So if an object or a material lost electrons, now it's missing some of these negative charges. Well, overall, it's now going to be positively charged. So when you're rubbing these together, electrons will be transferred. One will become positive, one will become negative. And in our second lesson, we'll talk a bit about how you know which one will become positive or negative. All right, now let's say that you have a charged object. So for example, after you rubbed your socks on the carpet, you became charged, and then you went and you touched something, something like a conductor, like a metal that's it's easy for electrons to move through. That's when you'd feel that zap. Okay, and we see this with lightning as well, right? How you end up with this charge, this static charge building up, and then it finds somewhere to escape to. It gets grounded. It finds a path to ground. And you see this zap, which is those electrons suddenly moving, right? That static charge suddenly has an opportunity to move. Now, most objects around you, they start off neutral, right? If they're not being rubbed or anything, generally they'll have the same number of positives and negatives, right? If we go back and look at this atom for a second, right? This is a neutral atom. It has, I don't think we can see all of them. Some of the blue protons are underneath there. I think it's a carbon atom, but there would be 6 blue protons that are positive and then 6 electrons. Oh, here we go, 6 protons, 6 electrons. The positives and negatives cancel out. It's neutral. 6 positive, 6 negative, neutral. And we call those neutral. Right? So as long as there's the same number of each. So often, oftentimes objects will start off being essentially neutral, and then as they're rubbed with something, they'll either gain or lose their electrons. So let's look at kind of a simple demo here. So here I have 2 objects. I have a wool sweater and I have a balloon. And you'll notice that they start off being neutral. So here they all have positives and negatives. They're made out of atoms. So they have protons and neutrons and electrons in them. They have positive protons and negative electrons. So they start off neutral here. But what happens is, as soon as we start to rub this balloon on the wool sweater, now we can start to transfer some electrons. And what do we end up with? Now our balloon over here has a bunch of extra electrons. We would say our balloon is negatively charged. And our sweater is missing a bunch of electrons. So overall, it now has extra positive charges. And you'll notice that when I let go of this balloon, it starts to move, and we'll talk about that in a second here. All right, so that moving is something called the law of electric charges. What we've found out is that different charges will actually either attract, pull towards each other, or repel each other, push each other away. So if you have opposite charges, so if you have a positive thing and a negative thing, those objects will attract together. So in this example we just saw here, after we rubbed the balloon, we had a positive sweater. It has more positives than negatives. We had a negative balloon. These things are opposite. Positive sweater, negative balloon. Opposites attract, and those will actually pull towards each other. And they would stick together. And if you kind of left them undisturbed, that balloon would just keep stuck on the sweater there. And if you have a balloon, you can try this at home, right? Rub it on your hair, give it a charge, stick it against a wall. If you have like charges, so let's go back here. Let's say we created two different balloons. I can reset this with two balloons. Let's say I made, I rub it on here and I make one balloon negative, and then I'm going to go and I'm going to make the other balloon negative. You'll notice that these two negative balloons, they're now actually like pushing each other away. So we say that like charges, the same charges, will repel. They'll push each other away. A balloon's pushing that one quite quickly when I release it here. Right? It's also getting attracted to the sweater. So like charges, if you have the same charges, they'll repel. They'll push each other away. So if you have two negatives, they'll push each other away. If you have two positives, they'll push each other away. Now, a neutral object, it will actually attract to either one. Not as strongly, but a neutral object will attract to either one. So if you have a neutral and a positive, it'll attract, or a neutral and a negative, it'll attract. So really, the easiest way to think of this is that if you have the same charge, they're going to push each other away, but any other scenario, as long as they're different, they will attract together. All right, so let's look at this here. First example, I have two objects. They can be, in the lab, we usually use little pith balls. They're just like little balls of foam. But these could be balloons or whatever. You have two objects. You give one of them a positive charge, one of them negative charge. If you stuck these beside each other, they would attract. Right? They're opposite charges. They would pull together. Next example. You have two objects. They're both positive. You put them near each other. You release them. And in this case, they would push each other away. So like charges repel. Here I have two negative objects. I put them near each other. They are like objects, so they will repel. They'll push each other away. Last one, I have a negative object, and I have a neutral. There's nothing on this, right? Equal number of positives and negatives. In this case, they are different, so they will still attract. Maybe not as strong as the positive and negative, but they'll still attract. All right, so I have kind of some short demos here that you guys can quickly watch, and we'll describe them as we go here. So he's going to be taking these balloons, giving them charges, and then seeing what they do to each other. All right, so first thing he does, charging the balloon by rubbing with a cloth. Okay, so he rubs the balloon with a cloth, just like the sweater. There's some electrons being transferred because they're rubbing. So the balloon ends up with some extra electrons here. All right, so here he says, yep, oops, sorry, a extra negative charge. Now you'll notice he does the exact same thing with the rod there. We kind of missed it here, but so now he's going to rub the rod, and in this case, it also has a negative charge now. So we have a negative balloon and a negative rod. In this case, Like charges are both negative, they should repel each other. And you'll notice he can just kind of push the balloon away without even touching it. Right? That's because they're both negative, and negatives repel. They push each other away. All right, next demo. Okay, in this case, same idea. Here he just made two balloons. He made both of them negative by rubbing them with the cloth. And once again, those two balloons are both negative. They're repelling each other. They're pushing each other away. Okay, so he starts off with two neutral ones, rubs both of them. They both become negative, and yep, they just keep pushing each other away. Right? Like charges, same charges, repel. All right, now what he's doing is he's bringing in this negative rod that he had from earlier. Okay, in this case, everything is negatively charged. Each balloon is negatively charged. The rod is negatively charged. That means everything is going to repel. Like charges repel. So you should be able to kind of push everything around with this rod without actually touching it. Right? See that it's acting at a distance. Now, here's the weird one. Now he's going to bring in a piece of wood. This is a neutral object, and he's going to put it in between. Okay, what does a neutral and a negative do? Those are different, so they attract. You'll notice that it pulls both of the balloons in. The neutral and the negative attracts. Right? Different charges attract, same charges repel.